Hello, I am Sugadan Vallot, a faculty member of Agnel Technical College, Bandra, Mumbai, welcoming you to this lecture on orthographic projections. In this lecture today, we recall the principles of orthographic projections in first and third angles that we had learned in the last topic. Newly, we learned the visualization principles of orthographic drawings, how the dimensions of objects are seen in the orthographic views, different types of orientations of planes with respect to the projection planes and their views, different types of planes and their orthographic views. This will be helpful in drawing the orthographic projections of objects. This will apply in some of the exercises that we do as assignment number 1. Coming to this slide, we see the first angle method of projection. In the first angle method of projection, the object is kept in the first angle and it is between the viewer and the projection plane. The projector lines are going away towards the projection plane from the observer. Here we see the three views: the front view, the right hand side view and the top view. When the planes are opened up, they are seen here positioned with respect to one another. The top view is below, above that the front view, and on the side of that the right hand side view. The right hand side view is seen on the left side of the front view. In the drawings, a first angle projection is represented using this symbol. Here we see a truncated cone being projected. The left hand side view will show us both the smaller circle and the larger circle which is seen here. In this slide, we see the third angle method of projection. In this view, the projection plane is in between the observer and the object. Accordingly, we get the front view here, top view here, and the right hand side view on the right side of the front view. The three views are positioned with respect to one another in this way. We see the right hand side view on the right side of the front view. Top view is above the front view. This is a symbol representing the third angle. All our drawings being discussed ahead will be made in the third angle method of projection. The third angle method of projection, we can see three main planes over which the projections are taken: the front plane or the frontal plane, the horizontal plane and the profile plane. Corresponding to the right hand side view, we have the right hand side profile plane. There can also be a left hand side profile plane if we are taking a left hand side view of the object. Now let us see how we see the different dimensions of object in the orthographic projections. This is a third angle projection, the front view, the top view and the side view. We see the width of the object in the front view as well as the top view. We see the height of the object in the front view as well as side view, and the depth of the object is seen both in the side view and the top view. In order to visualize the orthographic projections and the drawings, let us see as an example different types of orientations of planes with respect to the projection planes. If I take a plane on an object, the plane can be oriented perpendicular to the projection plane. It can be parallel to the projection plane, and it can even be inclined to the projection plane. Coming to this, when the plane is kept perpendicular to the projection plane, the view obtained in the projection plane is a line. This is called as the edge view. In the second figure here, we see the plane kept parallel to the projection plane. The view obtained accordingly will be a true shaped, true sized view of the object. If the plane is kept inclined to the projection plane, the view obtained in the projection plane will be a foreshortened view, or a view whose dimensions are lesser than the true shape of the object. This we call the foreshortened shape. This is called the true shape, and this is called the edge view. Let us see some of the different types of planes normally found on objects which are to be projected on the projection planes. They are a normal plane, or a plane normal to the projection lines, a plane inclined to the projection lines, and a plane obliquely positioned with respect to the projection lines. Let us see one by one. This is an object with three sides parallel to the three projection planes. If we were to view the object from this side, this is the front side of the object, this is the top side of the object, and this is the right hand side of the object. If you take the projections of this solid in the third angle method of projection, here we see the front view, this is the top view, and this is the right hand side view. Unlike this, here we see an object which has got surfaces inclined to the projection planes. If we were to view the object in this direction, this being the front side, this being right hand side, and this being the top side, we get these views. This is a front view, this is the top view, this is the right hand side view. Let us see the projection of this plane obtained in the front and the top view. This plane being inclined to the front view is seen as a foreshortened shape in the front view. Similarly, in the top view also, this is seen foreshortened. There is the same case with surface C also. In the top view as well as the right hand side view, they are seen foreshortened. Now, surface A is inclined with respect to the front plane as well as the profile plane, and therefore surface A is also seen foreshortened in the front view and the side view. If the surface is inclined to all three projection planes, that plane is called an oblique plane. Here we have surface B as an oblique plane. When we see the projection of this plane in the three views. In all three views, this is visible. That is a specialty of a oblique plane. The projections of this plane will be obtained in all three views. Going ahead, let us see some of the specialities when we are drawing cylindrical or curved surface in orthographic projections. Coming to a cylinder, on this object we see a larger cylinder and a smaller cylinder here. When we are taking projection of this, along the axis of the cylinder, that we see as a circular shape. So we see here a smaller circle corresponding to the smaller cylinder and a larger circle corresponding to the larger cylinder. When we see the object from the side or top parallel to the axis of the cylinder, we see that as a rectangular shaped view. So the larger cylinder is seen as a rectangle here, the smaller cylinder seen as another rectangle here. In this we see a cylindrical object merged with a rectangular object. So this vertical surface of the rectangular object is tangential to the cylindrical surface here. We see that there is no visible line here. The line shown here is the center line of the object. We see here another object having a cylindrical inside surface. In this we see a cylindrical part merging with the vertical surface. Similarly, horizontal surface is also merging with the cylindrical surface here at the corner. Point to be noted here is that at the points of tangency, there are no lines in the view. Let us conclude the visualization principles of orthographic drawings. So far, what we have seen. First of all, a flat surface is oriented perpendicular, parallel, or inclined to a plane of projection. Accordingly, we may get an edge view, a true shaped view, or a foreshortened view. Second principle is all flat surfaces appear as either a line, a plane of true shape and size, or as plane of foreshortened size. Third principle is all surfaces appear in every view. With this knowledge, let us see the different types of lines seen in orthographic projections and their meanings. Now, this is the top view, this is the front view, and this is the side view of the object. Now, here we see a cylindrical object from which a horizontal surface has been cut here and a rectangular slot cut here. There is a hole here at the center. On this we see a number of lines named A. One here, another here,